Good evening, everybody. Welcome to another BCS SIGIST webinar. So tonight we're going to be talking about ISTQB and cracking software testing interviews. So we have Sujata Sinha here, who's going to talk about her personal experiences with ISTQB, changing career, and it should be a really interesting deep dive into this topic. This follows on from a deep dive earlier this week into testing apprentices. If that should be on YouTube soon, if anyone missed it, it was a really good exploration of the apprentice track for software testing. As usual, please post any questions you've got on the questions pane. At the end of the presentation, we'll go through those questions and Sujata and I will try and answer them. So Sujata, welcome.
Hi. Thank you, Adam, for having me. So good evening, everyone. Thank you for joining this webinar on ISTQB and cracking software testing interviews. Before I start, I would like to introduce myself. My name is Sujata Sinha, and I am working in the software testing industry for the last 10 years now. So then I came in this country about, I would say, 17 years back. Quite new change of culture. I always wanted to do something, like I just wanted to work. So I started working in a charity organization, to be honest, as a volunteer, first of all. And then later on, I was working on a web-based application as a volunteer. Did that for 7 long years, got a paid job in that organization. But then later on, I thought to do something else. So I was a psychology graduate from Delhi University in India. So I thought to, move on into software testing. And because I was working with a voluntary organization, I could see that, volunteering was a very good opportunity to even change careers. So I got into an organization where they were looking for someone on a voluntary basis who could look into their documentation, like the specification. It was quite basic, but I started doing that. And then I got the certification, which was like foundation level ISTQB certification. And once I did that, I think that was the turning point. I did have my contacts, of course. I spoke to people that I'm looking for to change career, and on LinkedIn that helped a lot. And then I got my first break in software testing in Capita, which was like, it was really thrilling for me because I was not expecting an organization like Capita to take someone who has, to be honest, never worked in software testing. But I did get the opportunity, and I would say that the ISTQB certification helped me a lot in understanding the whole process of software testing, and also understanding how important, especially on an interview stage, how important it is to know the terminologies, the correct terms to be used, so that you can crack the first stage of getting into an organization, especially when you are new or you're a fresher. Then that helps a lot. So today I will be touching upon the following. So people that are new for software testing, I'll explain a little bit what it all has in it, what it means. And then I'll be moving on to ISTQB foundation level certification course and what it has in it, which can help individuals to get into software testing job. And I will be touching upon some basic questions from each of the chapters of ISTQB foundation level. And people that are new, say freshers or people that want to change career, how this can help, removing their uncertainty or enhancing their confidence. I'll touch upon that also. And what are the prospects that after you become a software tester, what are the career prospects later on, say after 2 years, 3 years, if you're looking to have a growth in your career, what are the other options? I'll be touching upon that. And at the end, we'll keep the floor open for question and answers. So if you're new to software testing, the first thing that comes in mind is like, what is software testing? And why do we need to do testing of a software? So the main thing is that we as testers, we want to make sure that whatever the application is designed for, it's doing the functionality is working correctly. So basically, we testers, we are trying to find out whatever the application has been created for, it's doing that. So we verify the functionalities based on the client's demand. So say, for example, if I take the example of a pen, and a manufacturer has created this pen, and the client's demand was that I want the cover to be, say, red color, or I want it to be pulled out so that user can open and close it with a click, that kind. So that is a user need which that manufacturer is going to create in such a way so that it's fulfilled. So basically, software testing is trying to find out if the application does what it's supposed to do. So in a nutshell, software testing is that. But I say that, but it's not only that. There's a lot involved in software testing because it has to have a proper robust process in place, because of different reasons, because of certain industries, they need there's a legal requirements for software um, testing to be done in a particular way. Very robust process has to be in place. So it's not very one liner, like the application is doing what it's supposed to do. It's much more than that. There's planning, controlling, monitoring, all that comes under software testing. The various processes in place, and in ISTQB's foundation certification level certification that I'm talking about, all these are covered in that. So what is expected from a software tester? To be honest, anyone who has worked on an application, has an analytical and has a curiosity to look out for what's not working well, could become a software tester. But saying that, there has to be also what you say, a balance in personality, as of a software tester's job is to find out issues, but we have to keep in mind that the issues that we are finding out is of is is that of a developer, because those are the people that are creating the application. So there has to be a very professional pessimism kind of thing in a software tester, so that they do tell the developer that, fine, there's a bug, but then there has to be a balance, as of to make sure that they're not pointing out a fault of that particular person, but we are all trying to achieve a collaborative goal. If we want to make the application really good, the quality has to be good. That's why that software testing is necessary. Now, software testing and quality, they come hand in hand. So in software testing, there's a lot of quality management, quality control that is taken care of. And coming back to ISTQB foundation level course, all these things are given in detail, as of software testing also helps in mitigating risks, because we want to make sure that when an application goes out there in the market, then it has the reputation of that particular company that has created the application has to be in good light. So those kind of things are covered in ISTQB foundation level course. So before I move on, this is something which I wanted you guys to have a look, because you can see that foundation level certified testers course is the starting point. So anyone who would like to get into agile testing, or say become a specialist of performance testing, acceptance testing, or maybe wants to go ahead into test management kind of thing, there are various paths which leads to that. But again, to get into, say, for example, agile testing, you can do testers course, you can do straight away. But to get into, technical test analyst certification, you have to first have the foundation level certification, and then you could step up and move on accordingly. Okay, so moving on. So the ISTQB course foundation level, I'm just touching upon. Most of you must be knowing that ISTQB stands for International Software Testing Qualification Board, and this certification is recognized internationally. So in the foundation level course, there are 6 chapters. I've mentioned it here. Fundamentals of testing, testing through the software development lifecycle, test design techniques, static techniques, test management, tool support for testing. So these are the main 6 chapters for foundation level certification. Now, before I move on, I always like to tell the trainees that are there in my class that it's very important that you put in your time very wisely in all these chapters. Therefore, the exam structure is like they have 40 multiple questions, and to pass the exam, you have to score 26 out of 40, which is, I think, about 65%. And the total time that you get is 1 hour. So what I would like to emphasize here, that if you get 25, unfortunately, you fail. But if you get 40 out of 40, there's no like distinction or anything like that. You just get a certification. So I have splitted out the questions, the number of questions that come from each chapter. So you can see the fundamentals of testing. I have mentioned 7 questions. So from this chapter, there'll be 7 questions. From testing through software development lifecycle, there'll be 6 questions. Test design techniques, there'll be 12 questions. You can see that this is a very important chapter, and you should give more time to this chapter so that most of the questions could be achieved. Static techniques, 3 questions. Test management, 8 questions. Tool support for testing, there are 4 questions. So this total should be 40. So this gives a direction to your preparation towards getting a certification. That's why I like to just mention this. So we will move on chapter by chapter and see. So these are just a very what do you say? I have picked out on the most important things that in an interview the person that is asking you questions could put across you. But saying that these are just the important things that I've picked up, but in reality the chapter is much elaborate. So the first chapter, which is fundamentals of testing, if an interview is going on and the person sitting in front of you is asking you, why do we need software testing? That is a common question that very casually in an interview this comes across. And the best way to go about it is that you could say that to mitigate risks, and then the person sitting in front of you will say, what do you mean by mitigating risks? So you have to have that understanding of the connection of risk with quality, with software testing. So you could say that an application cannot be tested fully in the if cannot be tested in the fully given amount of time. As you know, the release and project plans and everything, they have quite strong deadlines. So the identified risks that are there in an application have to be mitigated. That means there has to be a workaround that has to be in place, and that can only be done if testing is done on that application. Why is that? Because once a tester finds issues, it goes to the developer, they try to fix it, it comes back for retesting, and if that bug has been fixed, then good enough. If it has not been fixed and there has been deadlines to be reached, there has to be a way to mitigate those risks. It could be anything. It could be going back to the stakeholder and finding out what can be done. Can we push it to the next release? Things like that. So risk mitigation is more about, there are two things: that we know that there is an issue in the application. If we know, how do we have a workaround for it? Can we live with it? Those kind of things can be taken into consideration through software testing. So what happens if we don't do software testing? What or the person can casually ask you, what do you think can happen? And then the point is that if we don't do software testing, there'll be risks. That there'll be risk of having a bad reputation in the market because the application doesn't work properly, or even some industries like say medical industry or aeronautics, where airplanes and all that machineries, where there is life involved. If proper software testing is not done, then it can be lethal. It can cost life. Not only money, of course, money, because there'll be so much investment done in creating those applications, but it's also risk to both money, life, reputation of that particular company. So you can see how important software testing is when it comes to um, launching an application properly. The third point here: when do you think an application has been tested fully? Well, if if a manager comes to you and says that has testing is testing complete on your application, actually you can turn around and say, well, this is not the right question, because testing can never be fully done. Why? Because all particular scenarios that a person can think about, it's just not possible. Exhaustive testing is not possible, because you as a software tester, you're sitting there based on the information that you have. You're looking at all the information and you are identifying scenarios to test. But you have identified a set of scenarios and tested that. But there could be someone else who has a different mindset and comes and could have a different scenario which you have not tested. So all the combination and permutation that will be there for testing in an application is not possible. So you can say that all the scenarios that I have identified based on the document that has been given to me has been tested, but that doesn't mean testing is complete. Okay. So, and then in this ISTQB certification course, it very nicely explains. So when do we know that enough testing has been done? So again, I don't want to go into detail, but it's the job of the test manager to have some exit criteria as of, okay, fine, if we have, say, 5 issues in this application with medium severity, it's an acceptable application. So those are the things that, there has to be a balance maintained. That's called risk management again, if you think about it. So yeah, so the last one is, what is early testing? Early testing is one of the principles of testing according to ISTQB. What it means is that the earlier you get software testers in the whole process of software development, it's cost effective, because the earlier you find defects, it's it's cost effective to fix it. So when I say early testing, I would say things like going through the document. It's also called static testing. So when a client has given their specification, it's on a document. So it has to be reviewed, it has to be read so that issues can be found there itself even before the software development has started. So you can see that time and money and the cost that is going to be incurred in all this development can be saved because of early testing, and that is what early testing is. Moving on to the second chapter, which is testing through the software development lifecycle. In this chapter, mainly they talk about various software development models, and we know that the most traditional, and there could be a question like, could you give some example of software development models, and why do you think agile, which is iterative incremental model, is very popular these days? So the best way to answer it is that the most traditional model of software development lifecycle was waterfall model, and in that early testing was not done because testing would only start when the software was developed. So you can see that once an application has already been developed and then you start testing, the whole process has to go back. The specification has to be modified. The application that has completely been, it has been created with all the money and effort and time of the team. It has to be again, going back and again making fixes can be more expensive than if we do things earlier in the stage. And that's why they introduced agile approach, which is an iterative incremental model. That means that we have certain small sprints in which we decide that five functions will be in our first sprint. We'll only develop those five functionalities. And in that sprint, there'll be testing also for those five. So you can see that, while development, there's testing going hand in hand. So it's not like the whole product is ready and then testers are introduced. It's parallelly done, and that is more cost effective and efficient way of doing it. That's why agile approach is quite adopted by organizations these days. Now there's a term functional and non-functional testing that is often asked in interviews. What is the difference between functional and non-functional testing? So sorry. So basically, functional testing is like when you're verifying the user requirement. So say, for example, there's a banking software, user wants that the login function should say after two incorrect password and username combination, on the third attempt, it should get locked. It's a banking software, it should get locked. Basic functionality, I'm just giving you an example. That's functional testing, that you as a tester will do that and test if it's behaving accordingly or not. Non-functional testing is more about the behavior of the performance of that particular application. That means, say for example, if there are 100 users on this banking software doing 100 transactions, what is the response time? That kind of thing is non-functional testing. And it's very important to give examples in interviews, because then it gives an idea that you know what you're talking about. Now, non-functional could be load testing, as of if we have 1,000, 100,000 number of users on a particular application, what is the response time? Those kind, or maybe stress testing. Stress testing is done deliberately. They want to break the application, and that is what is known as stress testing. So what happens, they'll keep on increasing the number of users, and there are tools to do that. You don't have to physically have users for that. So you increase the number of users, you increase the number of transactions, and you just want to keep on increasing it until the application breaks. So that could be stress testing. So you are looking at the performance of that particular application. Now, regression testing is very commonly used. Difference between retesting and regression testing. So regression testing is something that you want to make sure that after a bug has been fixed, things that were working before does not get affected or does not stop working or does not get affected adversely because of the fix. So that is regression testing. But retesting is just normal. When you raise a bug, it comes back to you and you won't test that particular bug if it has been fixed or not. Test design technique. This is the biggest chapter, and it has about 12 questions in the certification test. So first of all, why do we need test design technique could be a question that can be asked. So the main idea of having techniques to design test is just to improve the efficiency and optimize the skills of a software tester. So say, for example, if to check a functionality, if we have test design techniques that helps us minimize the number of tests with 100% test coverage, that is an efficient way of doing testing, of creating test design. So in ISTQB, I'm just touching upon very briefly, but they have black box and white box testing. And within black box testing, they have 4 techniques like equivalence partitioning, boundary value analysis, state transition, decision testing. So all these are very, very, what do you say, technical test design techniques. But when you go through it, when you look at those test design technique, it gives you an idea as of, if we all might be using it as a tester, but we don't recognize it that we are using it. So if, say, for example, if we want to test a range of things, if we just pick up one value from that range, that should behave correctly. So we don't need to say from 0 to 30, we don't need to do 30 tests. If that partition has to behave in a particular way, we just need to pick up one or two values from that partition, and it should behave in a particular way. So I'm just giving you an example of equivalence partitioning, but the other techniques also, which helps us testers to create tests in a much efficient, effective way so that 100% test coverage can be achieved. And why do we need that? Why do we need it? Because we have constraint of time. Every project is not like you can do it forever. There is a release date. There is a testing date that has to be, testing has to be completed by that date. So because of constraint of time and resource, we need test design techniques. Now, black box testing is quite commonly used in software testing industries. What it means is that you as a tester, you're not concerned about the internal structure of an application. When I say internal structure, I mean the coding language, or how has the coding been done. You don't need to know that when you're doing black box testing. And usually, especially end user acceptance testing, or even software testers that are not developers, everyone does black box testing. We all do black box testing. It might be that we don't use the term or we don't know the term. Why do I say we do black box testing? Because all we are doing is we are looking at a specification, trying to do what the user wants this application to do. Say, for example, I enter the username and I enter incorrect password. When I click login button, I want to see that an error message comes up. This is black box testing. I don't want to see how the coding has been done. I don't want to see inside of the application, but I want to just click buttons. I want to look at the behavior that of or specific. That's why black box testing is also known as specification based testing, because we are looking at the specifications that our customer has provided, and we are following that and verifying the application. So that is known as black box testing. White box testing, first of all, mainly done by the developers, because they know the coding, they know how the coding has been done. So they are looking at the structure of the application, internal structure. And that's why it's also known as structure-based testing. Black box is known as specification-based testing, and white box testing is known as structure-based testing. Now, the last one on this slide is exploratory testing, which is it's a third test design technique in ISTQB course. What this means is that based on the experience of the tester, the person comes and sits in front of the application, and based on his experience, he knows the area where there could be more issues. So if I think about it, I don't know if you guys have come across job adverts where it says that they want candidates to be working from a particular domain, like say for example banking or document management. And the reason behind having someone working from the same domain is that the person will have an understanding of the application. Say for example, if someone is working in a banking on a banking software, the person if goes to another company and works on a banking software, they will have an idea of what are the areas where the complexity lies. And that is where the experience of that individual helps. And that's why people want to recruit individuals who are in a company with the same domain, same business kind. And that I want to link it with the exploratory testing and experience-based testing thing, because whoever has that experience would come and they would just know the areas that would have issues. Usually exploratory testing is not very formal, because and it's usually used when there's time constraint, when the documentation is not good enough, and there are projects in which documentation is quite loose, and people don't know like what to refer to, and that is where experience based people, that testers that come in, they are of great value. I have touched test design techniques very briefly, very important chapter, and it's quite interesting. As of we testers, we do use techniques, but it's interesting to see how we don't call it as a technique, and when you go into the details, it's really interesting. So the fourth chapter is this one is quite small, I would say brief chapter, which talks about static technique. And I mentioned in my first slide that static technique is to do with early testing. Why do we call it static technique? Because we are not executing anything. We are not executing the test, as of we are not clicking buttons on the application. What we are doing is we are looking at the documentation. Now, coming back to interviews, it might be that they will ask you question, how important is it to have documentation in a testing environment? And the best way to respond to that is that early testing is the fundamental principle of software testing. It's best practice to do early testing. And early testing can be done through static testing, because static testing is nothing but looking at the work product documents. When I say work product documents, I mean functional requirement document. So whoever is the customer, he wants a company to create an application that does A, B, C. And that A, B, C is written in that functional requirement document or functional requirement specification. Different organizations have different terms. For some call it business requirement document. So if once that is written, it's even in ISTQB, you'll see there is a very important statement that says that testers should be involved once the draft copy of a functional requirement document is in place. So once a document is in place, a tester should also be introduced into meetings, into discussions, because that is early testing. Testers will go through the document and they will see if there is any ambiguity, if the logic makes sense or not, or if there's any missing thing in the document which has not been clarified. And believe it or not, there are so many things that testers find in static testing, and that is early testing, because developers are just discussing about the architecture or how to use the codes, and then they're not yet started working on it. And that is the best time to look out for bugs. We call it bugs again, even if it's going through the documents. It's testing, it's static testing. So in static testing, as I said, we go through the documents, and while going through the documents, it's called the review process. Again, terminologies are important. So in ISTQB, you'll see that there are various static techniques, and one is informal and the other one is review process. And review process is a formal way of static testing view, where you have proper meetings that are facilitated. There are moderators, there are scribes, there are people that take minutes, the people that take notes as of what has come out of the review process. And remember, the review process is nothing but we are looking at various documents. Again, in review process, there are very formal review, there are informal review, but for now, I think from interview point of questions that would come would be early testing, how it's related to static technique, why it's important because of time, money, which saves, and how do we do it? We do it through review processes. The fifth chapter is test management. Again, I think it's an important one because I think there are 7 or 8 questions from this. Now, another important term that comes in this chapter is author bias. And you may be asked question around, do you know what is author bias? And author bias is nothing but that is the reason why we need a separate test team. The first point here, why do we need separate test team, is because people that are developing an application, they will keep on looking at it 100 times, and you know that they will not be able to identify issues that a fresh pair of eyes, which is a tester coming from a different team, can point out and find more issues than dev team, because that is known as author bias, because that person that is creating that application will not be able to find out issues themselves, because they have been looking at it's just like writing a book. When you write a document and you keep on reading it, you will not be able to find issues in it, but you give it to someone else to review it. Can you have a look? Because the other person will have a fresh pair of mindset, a fresh pair of eyes and mindset to go through it, and that is why we need a separate test team, so that the software is looked upon independently. And and there is a term called level of independence when it comes to testing. So say, for example, what will be the level of independence if a dev team is conducting the testing on the application? The level of independence will be low because those are the people that have been developing the application. The level of independence will be high when a separate team, or say even a test team contractors are brought in to test an application. That will be the highest level of independence, because they don't know anything, there's no bias, they don't know anything about the application, and they have been asked to work on it, and they can give a fair um, feedback as of what do they think about it. And usually that's where user acceptance testing comes in, where users, they have the application, they go on it and they start working on it, and though all the testing has been done, but you'll see there will be issues that come when UAT is done. So again, in test management, um, there has been it has been touched upon static testing and early testing and review processes. Now, in test management, I have not put in here, but there are things like test planning, test control. So, though I did say that testing is about finding issues and making sure that it does what the user wants it to do. But in doing that, there's a lot of planning, monitoring, and control, and that these are the things that come under test management. So, if you're asked, what do you mean by test management? Then I would say there are four things, not three: planning, monitoring, control, and also risk mitigation. Because the managers are the people that decide as of what do we consider as high risk. And there's a lot, of course, there's a lot of meetings and with stakeholders that happens when all that is done. So in test management, um, planning, control, monitoring, and the whole process is defined in the course. They talk about test plan, test case, bug reports. All that is quite in detail in test management. Now the sixth chapter is tool support for testing. Again, quite a small chapter, but important, because nowadays organization, they do introduce tools so that testing can be done effectively, quickly, efficiently. So the purpose again of having tools is to increase efficiency if repeated tests have to be done, making sure that we could time can be saved. So things like test automation is done so that regression testing can be done efficiently and quickly. So the other thing that could be asked is that how do we implement testing tools? What is the best approach? So it has been nicely covered in ISTQB that you have to be really careful while implementing test tool, because it could give more harm, it could give more loss than gain. So that is where benefit and risk analysis has to be done before introducing a tool in a company. So for example, what about the policy? Have we got training in place? Do we have enough skilled people who can do automation on tests? Those kind of thing. What is the time factor? Um, is it going to take too much time? Those things have to be thought before tools are introduced in organization. And the best approach is to do it like incrementally. Pilot projects should be in place, and then if it's successful, then it should be rolled over across the organization. So these are the things that could be mentioned. Now we have covered on the 6 chapters I would say very briefly. When you go and do the course, then it will be, quite detailed, but this of course, helps in just trying to direct yourself and prepare yourself for interview sessions. Now, there are some terminologies that I have put in here. So risk mitigation, functional defect failure, verification, alpha beta testing. These are some of the terminologies that you could keep and understand before you go for an interview. So people that are new to software testing, or even they are trying to change career into software testing, there could be certain uncertainties and things surrounding, which is on the right side, and which I've tried to mention that confidence is something that that could hamper when it comes to interview. So I don't know, but the trick is that think about once the interview is over. Let's think that everything is gone fine. I that's my trick. I always think about once that's over, how good will I feel? So, and that way you could increase your confidence, and also think about your strengths. Think about people that praise you, and I'm sure you have, even if it's a working mom who is trying to change career after 5 years. Just think about how well you've grown up with your kid. That kind of thing. It does help when it comes to confidence. I think flexibility and adaptability is very important as well. And eagerness to learn, it's an ongoing process. There's never a wrong time to do the right thing. That's what I would say. So even if you're in your mid 40s, 50s, if you're looking for a career change, it's never the wrong time to do the right thing. Now, pushing boundaries of your comfort zone, this is something that I am sharing from my own experience, is that whenever there is a growth coming in your career, you will feel discomfort. That's human nature. But always think that that is where growth is coming. You are doing something different that will give you uncomfort. But once you've done it, the confidence level that goes up is enormous. So just be ready to push the boundaries of your comfort zone, because if you're very comfortable, that means it's not you're not growing basically. Then identify your strength. Awareness about your weaknesses is very important. Now, career prospects after software testing is that you could get into becoming a business analyst, you could become a test manager, project manager, or a product manager, because while doing a software tester's job, you are interacting with all of these people. Business analysts are people that analyze the functionality, talk to the stakeholders, document things. And when you do static testing, these are the people you talk to. So if you want to move from software testing to something else, and above all this, you could become a trainer also, like me. So it has a lot of career prospects. So yeah, this is me. If you want to connect with me, I am accredited trainer for ISTQB Foundation and test analyst certification as well. So do get in touch with me. I'm on LinkedIn as well. And thank you for listening. Any questions?
Thank you very much, Sujata. That was really interesting. If anyone has any questions, you can ask them through the questions pane. I certainly have one, and we have one logistical question. So there was a question about whether the webinar is being recorded. Yes, it is. It will be on the BCS YouTube channel, although that does take a week or two. And as for a content-based question, so Just, that was a really good presentation. There is some people who say that ISTQB is outdated and doesn't reflect the testing that they do. I think that is perhaps their bias in their situation. And personally, I think it is invaluable for collaboration across different teams and just understanding all the different concepts. But I'd love to get your opinion on that.
Yeah, I understand where person from, because if you look at the course, it's quite, traditional way of looking at things. When you say that, it's quite old-fashioned, but that is the foundation. Things have evolved in different organization. I would say things were, different organization do testing in different way. Even some people call the test plan test case, and all the other round. Things are very different in different organization. But I think the foundation is ISTQB. It has evolved. Different organizations have evolved out of it, and it might look as old-fashioned and outdated, but I think that is the foundation brick. If you understand that, you don't have to keep on doing what's written in ISTQB, but if you understand that, you can build a process on that and a very and strong process.
Thank you very much. Okay, we don't have any further questions, but if anyone has any questions afterwards, Sujata's email address is there on the screen, and I'm sure she'd be happy to take some questions later. So
Yeah.
it just remains to thank you, Sujata. Thank you very much for your time. That was a really good presentation.
Thank you.
Thank you, everyone. Good evening.